Well, hello again everybody. Well, today on the workbench we're going to be taking another look at this MasteRadio, and the model number for those playing along at home is the D110W. Now in this case the actual W stands for wood, because this cabinet is made out of wood. Now they did actually also make a plastic version of it. Now for those of you that watched my last video, you'll see that I actually took this radio apart in the garden. I pulled it all in pieces, and I didn't really explain what I was doing, but this radio was absolutely terribly infested with woodworm. It had holes all over it. So at the end of last week's video you actually saw me take this radio cabinet, and if you're wondering what I was doing, it was a little bit odd. I actually stuck it in the oven. Well, it spent about 5 or maybe 6 hours in the oven up at 60 degrees C. Because one way to actually kill woodworm is just to actually, well, basically put the radio cabinet in the oven. Now this radio cabinet isn't particularly large, it's probably a bit wider and a bit higher than a large loaf of bread. Maybe it's slightly bigger than that, but yeah, it's not massive. So this quite easily fits into a domestic oven. Of course, you better do that when the wife's out, or you will get asked a lot of questions. Now I was actually quite fearful when I put this in the oven whether or not the the ply would start to come apart, because some of the glues that these are made out of, I think things like the animal hide glues and stuff like that, if you actually warm them up, the veneer can start to peel off, and I was wondering when I took this out of the oven, would I just have bits of piles of rotten wood and sawdust. But to be quite honest, the 60 degrees C temperature didn't appear to have any effect whatsoever on the case itself. So I can't speak for all radios, but it does appear that this heating technique certainly works. Now I'm going to actually say that this heating technique has worked and it's killed all the woodworm, because basically based on the science, woodworm really can't survive any temperature above 50 degrees. So as soon as you can take the radio up to 50 degrees, you're going to kill them. You're also going to kill the larvae, and you're going to kill the eggs as well. But the reason that you keep it elevated at that temperature for maybe 5 or 6 hours is simply because although the radio might be hot on the outside, it might have reached 50 degrees. Obviously the heat can't necessarily get to the inside of the sections of wood, and maybe some piece of equipment, old furniture, that's got quite thick wooden sections. So the reason they're saying put it in the oven for 6 or 7 hours, that's to allow the heat to kind of permeate through the material, because obviously wood is a really good insulator. Now what I did is I took some thermocouple probes, and I managed to stick those thermocouples quite deep into the wooden case. So I was able to get a temperature reading from the the centre of the woodwork, and yeah, it sat at about 60 degrees for 6 hours. So I am very, very happy that we've actually killed all the woodworm in this radio, because it would be quite a risk for me bringing this into the house otherwise, because my house is full of wooden beams and things, and yeah, we don't want them going nom 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 and chomping away at all my wooden beams. Now actually the main reason that I chose this radio is because it was actually in such a poor condition. I really did quite like the the distressed nature of it, and a few people said, oh, you're going to rub it all down, you're going to re-veneer it. No, I'm not. I want to keep it exactly as it is. I'm only planning on doing an electrical restoration. If we can get it electrically working, fine. The reason I bought it is because it was so rough, and actually I did actually like all the woodworm holes, but I don't know if you can see. Unfortunately what I have done is, although I did say we've killed all the woodworm, I didn't have complete faith, so I went ahead and I got a wax crayon. Now I tried to actually get a really dark black and brown crayon, so all these hundreds of flight holes, I've actually gone ahead and I've filled them with wax, so they've all actually disappeared, which is a little bit of a shame. But the reason I've done it is because if I didn't fill them with wax, every time I look at the radio I would wonder whether or not it was still infested, and whether things were coming out of it. So I did doubt myself, so I've gone ahead and I've filled them. I think it's a bit of a shame really, because we've actually lost a lot of that woodworm patina, which I did want to keep. So I have just brought you in now for a little bit of a close-up, so maybe you can just see it looks as though it's got It looks as though it's got little pimples or spots. Well, every one of these was a woodworm hole, a flight hole, where the adult had emerged from the side of the radio cabinet. Now, there does seem to be something about radio cabinets. A few people have said it's the animal hide glue that's used, but they do really seem to enjoy chomping away at old radios, and I'm sure that for maybe many years this radio was stored in something like a damp shed, and it's actually the area that's damp that takes all the damage. And again, a lot of people say that if you bring a piece of furniture into a modern house, even if it's got woodworm in it, because we've all got central heating now and stuff like that, they don't like the low humidity, and they won't survive. But again, I didn't really want to take that risk. But hopefully you can see that all those woodworm holes have actually pretty much disappeared now. I was actually just going to put a coat of shellac on it just to stabilise the varnish, which is flaking off, just to stop it flaking off anymore. I did think of putting some shellac on it, but a few people, when I've spoke about it, they said no, that it'll all crack and it'll all fall off. I don't think it will crack and fall off. I think you can use shellac to stabilise an old finish, but I've got to admit, I haven't decided yet. We may even just go ahead and get a little bit of wire wool and rub it over with some bry wax or something like that. So got to decide what we're going to do with that. Now, on last week's video you did see me stripping this radio chassis out of the wooden cabinet, but that video was really kind of just messing around really, and one thing that I didn't do is I didn't actually talk. It was a silent movie, wasn't it? It was a bit of a Buster Keaton movie, but less fun. So that's what we did last time. I didn't really tell you anything about this radio, so I just thought we could take a first look at it together and play a little game of Where's Wally, because I would say that there's something missing from this radio. Well, actually it's not true. There isn't something missing. It's all there. Don't say the valves. The valves are here. We've got all the valves, but there's something missing. So let's take a look around this radio, take a first look together, and you can tell me. You can maybe leave it in the comments or shout it at the screen what's missing. So let's start at this side. Well, in this side there was a rectifier valve that would have fitted in there. We've just taken that out so we don't damage it. Then we had I think the next valve along was something like a pentode output valve, and then we've got a couple of RF valves that will go in here. Now this is a super het receiver, so one of them valves is the mixer and the other is probably some form of RF amplifier. Don't know, not looked at the circuit yet. So again, the top of the chassis here we've got an audio output transformer, and we can tell it's the audio output transformer because we just follow some of the wires. It's connected to our loudspeaker, which is here, and the loudspeaker is one of the types that's got a permanent magnet. Now I've just noticed looking round, I think we've got we've got a wire broken there, so I'm assuming that this must probably be from the pentode output valve to drive the this output transformer. So we've got a wire to fix there. Okay, we've got an electrolytic capacitor here. Let me bring you in because I don't want you to miss out. We've got a little bit of leakage going on here, and yeah, just to clarify, I'm talking about this capacitor and not my underwear. Let me bring you in. So here's the main smoothing capacitor, and this is one of those canisters that actually has two capacitors installed in it. So we've actually got the grounded end here that you can see it's black, but you can see that we've got a lot of white powdery stuff. So this has puked out its electrolyte over the years, and one side of it is actually grounded to the chassis. And just above the main electrolytic smoothing capacitor we've got a bulb. Oh, and I just noticed that the I don't know, the little dome, the little globe on it is it's a little bit wibbly wobbly, so we'll have to take this out very carefully, and I think we'll try to glue that back together. I guess we should test to see the bulb works first, because no point in gluing it back together if it doesn't work. But I do like to keep some of these things originally. This bulb has been in for quite a long time. Now, I don't know if I said earlier, but this radio, it comes from around 1946. It's that kind of vintage, so she's getting on a little bit. So we've got a couple of large screened enclosures. I'm guessing one of these is probably something to do with a local oscillator, and probably one of them is, I don't know, the radio front end tuning. Again, not looked at the circuit diagram yet, so I'm not sure. We've got big variable capacitor here, which you can't really see. That variable capacitor It's got a horrible waxy capacitor hanging off it. Let's turn the radio around again. So does it turn? Oh yeah, it makes a horrible creaking noise, but if I turn that you can see that the pointer's moving backwards and forwards, and the oh, very saggy dial cord. Yeah, got some saggage going on as well. So yeah, that seems to work. Speaker is unripped. Looks as though it's got a felt patch on it. I'm guessing maybe that's a repair, I'm not exactly sure. It's got a piece of felt on it there. Probably have to put a piece of cardboard over here, because something about speakers, they just seem to be, I don't know, they just attract things to them, don't they? Screwdrivers especially just seem to gravitate towards the front of speaker cones. So yeah, we'll go ahead and maybe put a piece of cardboard on that. Let's just turn it over. I think we've seen everything on that side. So what have we got here? We've got quite a lot of really horrible waxy capacitors, and yeah, there's lots of theories on the best way to treat these. My thoughts on really is that generally you're just better getting rid of them. There is certain capacitors that have got very low voltage across them which are probably going to be reliable, but there is certainly other capacitors which are things like the grid coupling capacitors. If you see a waxy capacitor, you should just change them on site, because they will be bad, they will fail, and when they do fail they're going to do a lot of damage, probably to an expensive valve. So certain capacitors you should change these out on site. Now there's a couple of other waxy capacitors in here which also need to be changed out for safety reasons, so we're going to maybe come on to that shortly. So this is one of the most interesting things about this radio. I just spotted down here what I think are some kind of intermediate, I think these are IF transformers down here, but they look as though they kind of, well, they actually look more like kind of transformers, but they look as though they've got, I don't know, ferrite cores in the middle of them that can be raised up and down. So again, don't know much about that at this stage, so we'll have to have a look at them. So you can also see hanging through the bottom of the chassis the other end of our electrolytic capacitor, and again this end looks a little bit bulgy, and yeah, I can see that we've actually got some leakage going on at this end as well. So yeah, we're definitely going to have to change that out. And I've also just spotted a couple of capacitors at this end. They look as though they're branded TCC, I think that's what they've got written on them. And again, these are going to be mica capacitors. So generally speaking, although we had a lot of trouble with those mica capacitors in the trio, generally speaking, mica capacitors are reliable. But like anything else that's getting on for 60, 70 years old, you can't necessarily guarantee it. So we did actually spot this waxy capacitor earlier, but what I didn't say is it does appear to be quite burned, so something's gone on here, it's failed at some point in the past. So again, just showing signs that these capacitors are really bad. So we got some controls on the radio. So this is the band select switch. I can't turn it at the moment because it's got no knob on it. Here's the tuning control, which I played with earlier, so that seems well, quite grungy actually. Could do with a bit of lube on there. And then at this end we've got the can't turn it on. Yeah, we got the on and off switch. And I've gone ahead and I think you saw in last week's episode we cut the wires off that, which I will explain shortly. And then under here we've got this what looks like a transformer, but it's only got 2 wires on it. So this isn't a transformer, it's a choke. And then we've got another resistor here. And I'm not sure, but I don't think this resistor here, this grey one, which has got all the core, it's got all the resistance wire exposed. I don't think this resistor is actually an original resistor. I don't think this should be in here. I think this is some maybe attempt at a repair in the past. So I said we were going to play a little bit of a game of Where's Wally, and of course, what am I talking about? What's missing from this radio? Does anybody guess what I'm thinking about? I'm sending you the telepathic vibe. So we've got a choke, we've got an output transformer, but we are actually missing something else. Well, what I was trying to get at is there's no mains transformer. Normally in a valve radio you have a transformer which would do a couple of things. It would drop the voltage down to, I don't know, to 6 volts to power the filaments in your valves, and it would maybe provide the feature of giving some isolation from the mains, maybe outputting a couple of 100 volts to run the HT supply to the valves. So that transformer isn't here. So the question that you've got to ask yourself is, how do you get from, for example, 230 volt mains? How do we get from 230 volt mains to, I don't know, 6 volts, 12 volts? How do you get from that to 6 volts to run these heaters? How do we do it? Well, I think as per usual for me, I'm probably getting a little bit ahead of myself. So let's have a go, and I'm going to do my best to fumble my way through this circuit diagram. Any bits that I don't know, I'll just make up. So what you can see here, we've got the antenna connection, which is coupled into the radio via a capacitor. Now in a lot of radios, this capacitor is not particularly critical, but it can be in these AC/DC sets like we've got here today. So this is a component you should really think about changing, because it can present an electric shock hazard. So we couple in the signal into the radio, and the first thing it goes to is our band select switch. So you can see we've got 1, 2, 3 sets of coils. Now those coils actually correspond with long wave, medium wave and short wave. So this is what we call a pre-selector circuit. So it makes sure that our valve amplifier here, it only wants to be looking at quite a narrow range. It wants to be either looking at the long wave, the medium wave or the short wave. So these are effectively filters, and they actually form a tuned circuit with the main tuning capacitor here, which is VC1. So depending on which position the band select switch is in, you will only get a certain range of frequencies being presented to our mixer valve. So this is a mixer valve combined with our local oscillator. So this stage here is what is doing the mixing, and the output of the valve here is through the anode connection. So this is what you would call a tuned anode. It's designed to oscillate at a particular frequency. It's optimized, which it's probably designed to oscillate at. Well, I don't actually know what the IF frequency is of this radio. I'm going to guess and say it's probably something like 450 kilohertz, which would be fairly typical for this type of radio. So we've got a mixer valve here, and of course the mixer valve's job is to mix the incoming frequency with the output of our local oscillator. So this is the local oscillator stage here, and again we've got another band select switch, another gang off the band select switch. So depending on which band we're set to, long wave, medium wave or short wave, this local oscillator here it'll be preset to oscillate at a certain frequency, which is going to produce the required downshift to produce our IF. So we squirt out our 450 kilocycles intermediate frequency, and that goes to our next valve here, which is valve number 2, and this is an intermediate frequency amplifier, and again it's got a tuned anode on it, and it looks like it's also doing some funky business here. I'm just trying to trace the output through here. So this is our automatic volume control, which is quite common. And the way that works is basically, if we trace all this back through the band select switch at the front, it actually puts a DC bias onto the grid of the mixer stage. So that's going to be used to actually reduce the volume. So if you tune into a very loud signal, it doesn't blow your ears off. So yeah, this wire here, this is our AVC line. Now the output of the intermediate frequency amplifier goes into our double diode detector stage. So that's going to actually recover the audio from our intermediate frequency, and then it's going to couple it into our output valve by C16. So this C16, this is a capacitor that often gives us a lot of grief, because if this is in any way leaky, it will actually turn on this output valve. It'll turn it on very hard, it'll conduct heavily, it will probably damage the valve, and it can also damage the output transformer. So whenever you work on a valve radio, you need to find all these grid coupling capacitors, and certainly this is the one that worries me most in this set, C16. We've got to find that and rip it out and throw it in the bin, because it will be bad. So yeah, so here's our output pentode valve, which is valve number 4. So you can see the anode of the valve is coupled to our output transformer, and the secondary side of our output transformer is connected to our speaker. So that's all good stuff. And now perhaps the most interesting thing to us here is actually the power supply section. So I believe that the most notable thing about this power supply section here, well, this is our Where's Wally moment, because I don't see a mains transformer. There is no mains transformer. It is without a mains transformer. So where is it? Well, it doesn't have one. So what you can see here, we've got our valves here, which don't need to be in any particular order, but basically we've got our 1, 2, 3, 4, 5 valves, and you can see these little half semicircles. So these are the filaments, these are the heaters within the valve. So what they've actually done is, rather than connecting all the valve heaters in parallel, which is what you would do in a conventional set, and then connecting those heaters to the output from, I don't know, a 6.3 volt winding of a transformer, what they've actually done is they've joined them all together in series to make a much higher voltage. And then you can see that actually that goes to this resistor here. And this resistor is going to drop the incoming mains, because here's the incoming mains here. We've got that's probably going to be our neutral wire, and then we've got a live wire. So you can see the incoming mains goes into this big resistor here, and then immediately feeds all of these valves. And then there's a tapping from this resistor which shoots up here and goes into our rectifier valve. So no transformer, it's all done with this dropper resistor here. So let's take a close look at this dropper resistor. Well, we can see that there is quite a big wire wound resistor here. So of course what you're thinking is this is our dropper resistor. This is the one that should be taking the mains and dropping the voltage down. Well, you would be partly right. Dun dun dun! This is actually an imposter. And you know what we do with imposters? It's snippy snippy snip 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 snip. Snippy snip snip. Bye bye. So as you can see, the mains voltage would come into the set, but there actually isn't a big resistor. What we're expecting to find here is a big power resistor to actually drop the voltage down to a kind of more reasonable voltage. We're going to drop down to maybe from 250 volts to maybe 200 volts to power the HT supply for the radio. But typically, I don't know, maybe 100 volts for all these valve heaters to be connected in series together. But where is this big dropper resistor? Because I don't know about you, I can't see a big dropper resistor, so where's it gone? So this is the mains cable that we actually cut off the radio in last week's episode, and I actually think it's doing quite a good job here of it's hiding, it's camouflaging itself like a viper on my bench, and yeah, those viper snakes are quite dangerous. Well, that's something that this mains cable has got in common. It's potentially quite a dangerous thing, so let me explain. So we were actually looking for a big dropper resistor inside this radio, and we couldn't find one, could we? And the reason we couldn't find one is, well, in some ways it's kind of hiding in plain sight, because this is the dropper resistor that they use. So if we take a closer look at this, let me just bring you in a bit. You can see that we have 3 wires. We've got a red wire, I'm going to call it a black wire, and we've got a wire here which is very furry. Now this furry material is asbestos, and of course, as many of you will know, asbestos can be very, very dangerous, and it's been probably responsible for hundreds if not thousands of premature deaths throughout the years. So the problem with asbestos is it has very, very fine particles, and if you breathe these into your lungs, if you look at it under a microscope, the particles of asbestos, they're really sharp and jagged like fish hooks. They have barbs on them, and once this material gets into your lungs, it never comes out again. Your lungs react to the asbestos. It kind of forms little cysts around it, and they can become quite cancerogenic. So we don't really like we don't like dealing with asbestos because potentially it's quite dangerous. If we actually look at we've got some asbestos here, but within the asbestos there is actually a wire. I'm just trying to tease it out. I'm just trying to find it. There's definitely a wire in here somewhere. Here it is. And I'm doing exactly what I didn't want to do. I am disturbing the asbestos a bit, but there's a wire here, and I'm guessing that this is maybe a nichrome wire. So it's the same type of wire that you find in wire wound resistors. So what you've got here, you've got you've got a resistance wire running down the full length of this cable, and you know, when you put current through a resistor, when you start to pull voltage and current through them, you get heat, don't you? You get dissipation. So because this nichrome wire gets hot, that's the reason that they've wrapped it in asbestos like this. So this cable is our dropper resistor. Now there is several problems with using these cables of dropper resistors. One of the biggest problems is that they get hot. So what people, the problem was that what people would tend to do is they would tend to have the cable maybe bunched up like this. So rather than being able to dissipate all its heat, if you actually screw the cable up, it will actually get very hot locally and it builds up hot spots. And I can actually see that on this cable. There's a section here which is actually quite burnt. I can see here that the cable has melted at some point. So what's probably happened is the cable has been maybe tied in a knot, or it's been bunched up and it's locally heated up and the insulation has burnt off it. And yeah, that was the problem with these cables. They tended to get hot, and if they were wrapped up they could start a fire. And in fact, one of the nicknames for these radios used to be, they used to call them curtain burners, because you know they did used to catch fire. I'm just wondering if I can just demonstrate that resistance wire. So let's just tease out the other end of the wire here. There it is. And you can actually see that the resistance of this wire, it's about 349 ohms, so nearly 350. Actually, I can immediately tell, because if we looked at the circuit diagram, it was actually calling up a resistor of around 600 ohms. It was actually a 300 plus 300 ohms, so we'll take a look at that. So what's happened is somebody has cut this wire short. It's actually overheated, somebody's cut it short, and that's why we had that other resistor inside. So they've cut off around a 300 ohm section, and to replace that 300 ohms they actually put a resistor inside the radio. That's the one that I cut out and threw away. So that resistor that I cut off, that wouldn't have been in originally. Somebody's put that in because they lost some of the resistive mains cord. So what I've done here, I've taken our resistive line cords and I've just gone ahead and I've connected it to my benchtop power supply. So we've got about 50 volts going across this. Now if this was installed in the radio, there'd probably be about, I don't know, maybe 150 volts dropped across it. So it's only dissipating a small amount of the power it would normally would. And I've purposely gone ahead and I've tied the cables in a knot here because, you know, sometimes we have bits of cable lying around and we want to get rid of it, so we tie it in a bit of a knot, don't we? We shouldn't do, but sometimes we do. So I've just knotted up the cable here, and of course because I've knotted up the cable, rather than the heat escaping just into the air, we've got cables overlaid one on top of the other. So what will tend to happen is we'll get a hot spot, and yeah, this is the kind of thing that leads to curtain burning. And of course the other problem is there's always a temptation to take this cable and it doesn't look very pretty. So what you might do is you might decide to hide it under the carpet, and of course if you do that it's going to be insulated, so again the heat can't escape, so it's going to get hot. So maybe a better example will be, let's just have a look at it under the thermal camera. But this cable is just kind of nicely warm, and it's kind of a nicely bed warming comfortable at the moment. Yeah, that's quite warm. Let's see what the thermal camera says. Well, as you can see on the thermal camera, this lead really does show up as kind of a bit of a ring of fire. So it looks like the ambient temperature of actually the cable where it's uncovered, where it's in free space, it's, I don't know, what's that, about 30 degrees, 30.9, it's jumping up and down a little bit. But let's get towards our knot. So when we get to our knot, it jumps up quite noticeably to, well, to about 45 degrees, so that's getting quite warm and toasty. I wonder if we can just replicate sticking it under the carpet. Let's try insulating it a bit. So I'm just going to replicate a piece of carpet here by dropping an old tea towel on it. Let's give it a moment to heat up. So there you can see again on screen we've got our cable, and you can actually see that it's the colour goes dull, so it has actually been insulated by our tea towel there, which is representing our piece of carpet. So let's just lift our piece of carpet away, and in theory that bit of cable should be a bit hotter under the carpet, so let's lift that off. And yeah, well, it's gone up to about 35 degrees, so it has jumped up, but that was only after a couple of moments. So yeah, you can see why these cables have a reputation for being called curtain burners, and why, if you're not careful, they could cause you quite a lot of grief. Well, before anybody goes ahead and complains that we haven't actually fixed anything on today's video, well, you can see I have done. I've gone ahead and I've fixed our wobbly light bulb. Oh, until next time, that'll do. Bye bye for now.